All right. Good evening. Hello. Okay.
Hello. Hello. Yeah, can you hear me right now? Okay, let's get started. Before we go to the lab 4, let's have a look, just have a quick look of the project. So in the project we need to use Wi-Fi to localize indoor. So it's basically build a simple version of Google Map for indoor environment. So for example, you bring your device and the program into the shopping center. You should be able to use the Wi-Fi information to identify what is the specific location are you in. So you may need to build like a database. So you can have a look of the background and the introduction for that. So I think there are 3 parts that we need to do. So the first part is to collect the data. So we can use the Wireshark or use your own program to collect the RSS data we need. Then we can analyze what's the feature inside and how can we do the algorithm to like do this kind of algorithm to detect the location for the indoor area. And the second thing is to improve, to build and improve your localization algorithm. And the third one is for the reports. Oh, sorry, I forgot to mention about the demo video here. So for the reports, we need to write down something probably a few pages. I reckon around 4 or 6 pages should be enough. So this kind of words in like the requirement for like 2000 and 3000 words is not compulsory. Just make sure you can like have everything in your report. That should be enough. And the demo video is just like demonstrating the how you use the program in a real world environment. So 4 things to be submitted. The first thing is the data set. It's just kind of what we are doing in lab 1 and lab 2. Just use the Wireshark or use your own program to build the data set and the code, including your algorithm and the program. And the report, we can have a look what will we have in the report and the demo video. So 4 things to be submitted. Let's have a look. What should we have in the report? So in the report, it's just like a small essay or small paper. You need to state what kind of algorithm do you have and how did you improve it and what is the performance right now. So you need to provide sufficient data to prove it. And what is the like format? Basically just the format stuff. I think that's all. So just like a very small paper. And the demo video. The demo video just show that how you run your program in the real world environment. Let's have a look. What will be the like demo video looks like? At the end of it, we will have some like reading list, and we can check. For example, this one, Spotify. We can search this one in Google Scholar. Let me try to do it right now. Just this one. Can you see that? just search on Google Scholar, then you can have a look of this paper. You can have a look of the abstract, and then you have an overview of this paper. And then they do have some like demonstration video inside here. You can have a look of this video. It will have some demonstration inside, so you can just have a look how they show their program like this. You may need to have this kind of slides for your demonstration, but it doesn't need to be very long, probably less than 5 minutes. And that's it for the term project. So we still have lots of time to do it. Just let me know if you have any trouble. And we will have some help session start from week 6. Every week we will have some help session. So if you have any doubts or trouble, just post it on the forum or come to the help session. And let's get started for the lab 4. Lab 4. I will copy the link to the chat. The task is pretty easy. It's to use the API, system API, to fetch the Wi-Fi information. So just to show what I have here. Usually we use this interface to manage our Wi-Fi, right? This kind of data, as you can see here, I can see what is the SSID, what is the like model manufacturer, and what is the band we are using, what is the frequency and the speed. So how can we get this kind of information in our program? For example, you are doing the assignment right now. You need to calculate or estimate the distance from your computer to the Wi-Fi hotspot. How can we do that? So firstly, we need to figure out like how to fetch this information in the program. For example, Python program. How can we do that? So you need to use the run command because I am using the Windows. So run the CMD. In task 1, we use this command. Just copy this one and paste. And you can see in the terminal, we can fetch the information for the Wi-Fi. For example, this one, it have the signal this much, signal this much. As you can see, this Wi-Fi, they do have 2 bands, SSID1, SSID2. Actually, it's 2 different Wi-Fi, but they have the same name in different bands. This one is 5 gigahertz, this one is 2.4 gigahertz. And this kind of thing. So this is task 1. Just simply copy this command in your terminal and try to run it. So how can we use this command, this output in our program? Because as you can see here in the task 2, we need to design a program that input is like this. We use Python 3 to run your program, which is called Wi-Fi distance. Then you will have some outputs like this. It will output there are 3 Wi-Fi around you, and the frequency is this much, and they are using this channel, the signal strength, and the estimated distance in here. So how can we use Python to run this one? Any idea? Let me try to show you on the Jupyter notebook. Jupyter notebook. I already typed something in here. So in the first line, I would like to introduce two libraries. The first one is Subprocess. So this one can help us to run the terminal command. And this one is to check the OS version. As you can see here, I print the SYS version. You can see here are the Python version plus the system. So probably we need to check the system version before we run the program, because we may test your program in different system. So you may need to check if this system compatible with yours. And the second thing is just simply run the command as we did in the terminal here, this one. The command is this one, right? Net sh wlan show networks. So we just copy the command in here by using this function to call it. So I can show you the output. So the output is like this. And the next step is to extract the signal and extract the channel from the string, right? So this one is a long string. We need to manipulate this string to extract the information we need. For example, here, signal 92% and channel 157. So how can we do that? In here, I will show you how to do with the regular expression. So I use this regular expression library, then apply a search. Let's search the signal at first. So we want to search this kind of pattern in the string. It's out, right? So it can match this one. So what if the value will change in the future? So we can use regular expression like this. And see. So if we only need a number here, we can add a quote up, and then we can use the group function to output the value 92. That's how I get the signal strength. Of course, you need to modify the regular expression here. But I have shown you the basic idea of how I extract this kind of stuff from the long string. You can try it by yourself. For example, another one is to find the channel. I need to print the channel and the band. I can just copy this one. Channel. And channel should come just reflect this one. Yep. And modify this one. Space. Yes, we don't know how much space do we have. Okay, so that's the way I can match the number inside. And another problem we may have is how to switch this 92, because as you can see in our terminal here, you can see this one, the signal is 60%. So how can we convert this 60% to dBm? We had a discussion in the tutor group, and we think this formula can help us to do the calculation. For example, this one is 92, right? How can I convert to dBm. So convert to dBm. Then we can use this function if so we call this RSSI if load RSSI might equal to 0, then dBm equal to this, and then else if the load this one larger than 100, then dBm equal to -50, and else dBm equal to this one divided by 2 minus 100. Sorry, this one should be EL if. Sorry for the syntax mistake. And then we can simply bring dBm in here. It's -42 of 54. Sorry. So you can use this simple conversion in your program to convert the percentage to dBm. But of course, you can use your own method. You can investigate how can the Windows system convert the dBm to RSSI. But in this lab, we just want you to have a try of how can we use the Windows API. So don't worry too much about this kind of calculation. And another thing is about this equation, because we want to estimate what is the distance from our computer to the hotspot. So how can we do this kind of calculation? So why this one is 7 meters here? We can have a try. So just copy this one. Let's go to the calculation here. What is the frequency? It's channel 1, right? So we can go to the Wikipedia for the list of Wi-Fi channel. I send it in the chat. You can open this page. So for the first one, let's have a screenshot. The first one is channel 1. So the frequency is this one, 2412 for 2.4 gigahertz. So I just copy this value into our equation, replace the frequency with 2412. And what is the signal level? Is 57. So it's 57. Then the output is 7. So it's 7 meters. And the second one is the on 5 gigahertz. So we just go to the table 5 gigahertz, channel 9. Channel 9 on 5 gigahertz in here, this table, 5045. So 5045. And what is the signal strength? It's 60. So the distance is 4.7.727. Yeah, that's correct. So you can use this method to do the calculation. So I think you may need to have a table inside your program like this. You may need to have the dictionary or list or tuple for this one. So for the 5 gigahertz for channel this, and the frequency should be like this. Is that okay? And for some computer, for example, my Mac OS does not have the frequency in the output. So how can we like get the frequency if you can get it? Yeah, so because it doesn't show band in some case, so how can we do that? In this case, because in the API, it doesn't show us the frequency, especially for Mac OS. So we can use the channel to estimate what is the frequency. For example, here, you can see for 5 gigahertz, the channel starts from 7, right? And you can check if Australian allow them to have this one or not. No. So because of the regulation inside Australia, for 5 gigahertz Wi-Fi, the channel should start from 32. So this one, probably we should change this one, because like in general idea, our 5 gigahertz channel should start from 32. So you can consider if the channel number less than 32, it should be a 5 gigahertz Wi-Fi. So that's the first way we can like have a guess of what is the band and frequency we have. So we can have a look of the channel number, because we know that for 2.4 gigahertz, the channel is start from 1 to 14. But for 5 gigahertz, as we have in the table here, it should start from 32 to 190, 190 what? 196. Yeah, so the first thing is we can use the channel to estimate what is the frequency. And of course, you can also check the SSID. Let me show you. As we can see in the list, for example, when you check the name for each Wi-Fi, then you can see they may have some frequency information inside the name of it. So you can also write down an if command to have a look of the SSID. If they specifies 2.4, usually they are 2.4 gigahertz. If they are specified they are 5 gigahertz, then you can just say that they are using 5 gigahertz. So if you cannot get a frequency directly, you can use this kind of a method to estimate what is the frequency for that. So I will upload the recording later after the discourse. And I will also like put a note on the GitHub link about this kind of question we have. Please let me know if you have any trouble. We still have 1.5 hours. So you can try to do this one by yourself and let me know if you have any trouble. And of course, for the assignment, if you have any doubts, just let me know. I'll stay here until the end.
I have a question about the project assignment thing.
Yep.
So are we supposed to be able to figure out our longitude and latitude, or is it just like we are in this store kind of thing?
So for this one, we want you to like specify where are you in the shopping center or in the campus, inside the building.
Okay, so you're not supposed to like be able to find out exactly the position you are, sort of thing, or
No.
like
So you can draw a map in your program, or you can simply use the string to show that, for example, the input, we should not have any input, right? We just simply run our program, and the program should be able to tell us where we are, for example, inside the store, for example, inside the codes, or inside Woolworths, or
Okay.
at the front door of Commonwealth Bank, something like that.
Okay, I get it now. Thanks.
Okay. Please remember to attach a screenshot of sample output of your program. And yeah, just let me know if any doubts. I will stop sharing from now and stop recording so you can share your screen if you want.